elements with at least k getter values. You are given an integer array nums of length n and an integer k. An element in nums is said to be qualified if there exist at least k elements in that array that are strictly greater than it total number of qualified elements. Okay, so apart from this, how many elements are greater? It is 0, and for this one we have 2, and for this 2 we have 1. K is 1. At least k. Okay, so 2. If n minus I plus 1 is greater than or equal to k, n is equal to I. Okay, for this 5 we have it in the sorted order. For this 5 we want how many elements are there which are greater than this. Okay, so for this we have k equal to 3. Okay, so this, which is 6 minus 0 plus 1, which is 6 minus 1, 5. So here we have 5 elements. Okay, these are greater than or equal to 3, so this is qualified. Again, this is qualified, but this is not qualified because 6 minus 3 plus 1, which is 2, so this is not qualified. Also, if there are two elements which are same, what we do is, if this is equal to this, okay, so this is not equal to this, then we can calculate. If this is equal to this, then definitely we don't need to calculate for this, we have to calculate for the last occurrence. But maybe for this we have 2, so for this we may calculate. So we want the last occurrence of 4. Okay, we want the last occurrence of 4 for this, and then we will calculate how many elements are there. I just got confused about the lower bound part. Okay, it is n minus 1. Then this should work. We took a lot of time in today's contest. Okay, maximum substrings with distinct start. Okay, you are given a string s consisting of lowercase English letters, return an integer denoting the maximum number of substrings. You can split s into such that each substring starts with a distinct character. Okay, we are given a string s consisting of lowercase English letters. Okay, it's a simple problem, I guess. Oh, okay. See, okay. If we have a b, then we will choose the first character because it is not present like in the start. So we have something which is started with a. Okay. So then let's move ahead. Okay. Till this point now, have we taken b? No, we have not taken b into consideration. Okay, let's take b. Now for the next characters, we will check if we have taken this, we have taken this, we have taken this. So we can just take this as a complete part. If there is a possibility that the next character can be a possible valid start, then only we omit that. Else we'll always take the next character also. So if set dot contains this character, then we will just simply do I plus plus else. Else what we'll do is I plus plus. I think I plus plus, but ans plus plus as well. So this can just come here. So this is not present in the set. Send dot add s dot Okay, if this is not present in the set, we'll just add it in the set for the next character. Okay, this is present, this is not, this is not, right? Okay, we'll add it. This is present, no need to do, we need to do nothing. Then again this is present, yeah. So this should work. Why 4? Two, four, one. Minimum absolute distance between mirror pairs. Okay. 20 minutes. The first problem took a lot of minutes. Okay, minimum absolute difference between mirror pairs. You are given integer enums. Return the minimum absolute distance between the indices of any mirror pair. Okay, we have to find the closest mirror pair. One to 2 n is 1. 2 and 4 is 2. Okay, seems like a simple problem. Seems like a simple problem. How we will do it? How will we do it? Like, let's say okay, let's say we have something like this. For every element, let's say R1, we will have all its reverse, or what if we add the position of every element, or maybe for a particular element all its indices. Okay, we have the indices for all the elements. Then for a particular element we will, okay, let's say here it is 1 or something like this. For this we will find someone which is close, like someone whose difference with this is minimum, and we will do this for all these things. So I'll iterate it, so it would be n into, and we have to find this part in login. What is the login part? So is this a monitoring function? Like, let's say some element is over here, then the difference from this is greater, this is less, again this is less. So this is some kind of peak formation. But can I apply monotonic search here? Binary search for this monotonic function. For some function I have to, for some element I have to find the nearest element. If we find a peak, then maybe we can try binary searching in both of the parts. But it is more of a valley than a peak. Okay, so for every element, can I keep track of where was the reverse last seen? So this will give me a fair idea. So 1 2 2 1 4 5 3 3 and 5 4. 1 2 2 1 4 5 5 something was 3 3 and 5 4. Okay. If I have seen the reverse of this, okay, I have seen the reverse of this. No. So let's add 1 2 and its position is 0. Its reverse is 1 2. Where I have seen it? I have seen it just here. So it is 4 2 1, it is 1. And my answer currently is 1. Difference between this. Okay. Now when I'm here, I want the nearest, like the nearest number, which is 5 4. Maybe if 5 4 is present here and 5 4 is present here, I don't care about this. I calculated answer for this and I'll just update it with the new 5 4. I'll just update it with the new 5 4 so that I may get a difference which is just less than this, less than the previous one. Okay, in this way I'm just taking the closest one. Again, I'll take this for the closest one. So this has to work. I don't see any reason for it to be not working. I want the number and its position. What do I want now? What is the singularity of this? Reverse the string and get me the number. One, two, and three. Get me the number. RV minus I, okay, with the answer. This is the difference, and I just add mapped output the current number nums.I equal to what? Nums.I with I. Okay, I put the current number. I just calculated the reverse which was present. Okay, for this I calculated reverse. I calculated the reverse again. It was present over here. Then I added the current number. So yeah, this makes sense. One minus one, and okay, for 3 it was minus 1, for 2 it was 120 and 21. Interesting. For this the reverse exists. So should I do this for the reverse of the array as well? Okay, for this, the reverse was this. For this is not its reverse because we have a 0 here, but for this the reverse of this is still equal to 21, so that's why we got an answer here but not here. But why it is not present here? Reverse of this is 1 2 and reverse of this is 2 1. Okay, reverse of this current element should be equal to the next element. Reverse of the current element should be equal to the next element. Reverse of the current element should be equal to the next element, which means we have to reverse the array to do this. We have to reverse the array to do this. So what if we only store the reverse? If we only want the reverse, then let's just store the reverse. Map.contains key nums of this I. If this is present as a reverse part, then what we will do is we will get that value. Okay, and we'll just update the answer. 1 1 minus 1. Okay, the third one was easy as well. We just wasted time. I just feel like we have wasted time. The questions were pretty simple. What? 4000 rank. Okay, it will get updated, I guess. Menu operation to equalize subarrays. Now this is something which will decide. This is something which will actually decide. Okay, menu operations to equalize subarrays. Menu operations to equalize subarrays. We have about an hour. We are given an integer nums and an integer k. Okay, we can do it exactly by k. You can do it exactly by k. So for all these elements, should have a difference of 0 or a difference of k. For every element in this subarray, we should have a difference of k or 0. K or 0, so that we can make this guy to the next guy, we can make both of this to the next guy, then again we can take both like all these guys, and again we can increase it to the next guy. So the idea is, okay, I'll just close this for now. So the idea is, if you have a subarray like 1, 3, 5 and maybe 7, then in one operation we may increase this to this, so that we will get 2 3s. Then in other operation we can increase these 2 in this, so that we will get 5s, and again we will increase this to this, so that we will get 7. So the operation is 1 2 3, and minus 1 operations will be taken. On the other hand, what if we increase these ones, so that we were having 1 3 5 7, so we will increase this to 3, this to 5, and this to 7. So we have 2 7s, and again we have these 2 guys, so again increase them, so 3 4 5, so that it will get to 7, it will get to 5, again we'll have to increase it. So the better option would be take all the small guys, bring it to the next part, again take this all, bring it to the next part. Okay, so that we can do it in n-1 operations. n-1 operations, n-1 operations, or more specifically target -1 operations, if this is the target. Okay, pretty simple. But the only thing that we have to think of is the difference between all these guys is k. Like here k is 2, so is the difference between everyone is 2, like at least for the consecutive guys. Okay, so for this we'll have to loop. For this we have to loop like for the subarray, and we cannot do it for all this, we cannot do it for all the queries, because obviously the queries would be 10⁵, and the okay, it is 4 into 10⁴, and the length of the array is again 4 into 10⁴. Zero 1, difference is k. Is the difference k? Yes. Then the answer would be n-1, 2 minus 1, which is 1. Again it is 0 to 2. The difference between all them is 3, like for the consecutive guys. Yes, the difference is k. Then the answer is again n-1, which is 3 minus 1, which is 2. For this k is 2, okay, 0 to 2. The difference is not same, -1, clearly -1. Then we have 0 and 0. Okay, can we have the number as 0? No. Great. So we want 0 to 0, and we can increase it by k, which is 2. Okay, 0, wait, for 0 to 2 the difference was not same, so yeah, clearly it is -1. But then we have 0 to 0, which is this part, and we can increase it by k, increase and decrease it by k. Okay, we have to make all this equal, right? So yeah, one element is always equal, so we have 0, then 1 and 2. Again the difference between them is exactly k. Okay, so the answer would be n-1, which is 2 minus 1, which is 1. Okay, so we have partially solved the question. Now the problem is, how can we find that for a particular subarray the difference between the consecutive elements is exactly k? How can we do this? How can we do this? How can we do this? Okay. What is the prefix sum difference between any two elements? Here it is the element itself, I would say, or let's forget this for a while. This minus this is 2. Okay, so difference from this with its previous element is 2. Again it is 2, 2, 2. Okay, now what if I divide it by k? Then we get 0, 0, 0 and 0, which means that for every subarray here the difference is divisible by k. The difference is divisible by k. This is, by the way, the remainders. So whenever we get a query, we can check if everything in this is same or not. If everything is in this is same or not. How can we check this in least possible time? Maybe in login. Can we calculate the prefix sum? Can we then calculate the prefix sum? The prefix sum which was present at this point should be the prefix sum which should be present at this point or at the last, which means that this is 0, right? This is 0, which means that this complete LNR is having zeros. Yeah, this is some idea which we can build upon. This is some idea which we can build upon. This is some idea which we can build upon. So the thought process was pretty much clear that for this complete array, we will first find the difference between the guys, like the consecutive guys. Then what we'll do is, then we will divide it by k. Okay, then we will calculate the prefix sum. We'll divide it by k, then we'll calculate the prefix sum, so that whenever we have a query, we will check if this and this, if the sum is same or not. For example, let's take 1, 2 and 4. Let's take 1, 2 and 4 and k is equal to 2. We have 1, 2 and 4 and k is equal to 3. Okay. For this, difference with the previous guy is 0. Doesn't matter. The difference doesn't matter. Okay. or maybe we can take the element itself. Okay, let's say here the difference is 1, here the difference is 2. For this part, what should be the difference? Some of this should be the same as here, and it is 0, which means that we will not divide it. The remainder will be still 0. Okay, so 0 is fine here. Okay, now this is the difference. Okay, now we want to now we will divide it by k. So here it is 0, 1 by k, 1 to 4. It is the same, right? 1 to 4. Okay, k is equal to, k is just equal to 2. Okay, so here we'll divide it by 2, the remainder is still 1. We'll divide this by 2, remainder is 0. Great. Now let's calculate the prefix sum. Here it is 0, here it is 1, here again it is 1 plus this 0, which is equal to 1. Okay, these two guys can be converted, right? And these have the same elements. Why? Because the sum which was present over here is the same sum which is present over here, which means that nothing is changed. Legit, nothing is changed. Okay, now let's get to our queries. 0 2 0 0 1 2, 0 2 0 0 1 2. So 0 to 2, we have 0 to 2. Okay, what we checked is, we have to check if the sum of this minus this point, is it equal to the sum here. Now here no element was present, so let's take the sum till here, and this should be equal to this. No, this is not, so minus 1. For 0 to 0, the sum, should we always take the sum for the first, like the first position, or this L minus 1 position? This is question, this is a question now. Because this thing doesn't need to have 0 always. There may be some sum, there may be some sum, I'm taking the difference with the previous guy, so it is dependent on the previous guy. Again I'm taking the difference with the previous guy. Okay, difference is 2, difference is 1. Okay, now here I'm dividing it by, or what I'm doing, yeah, dividing by k. So I'm dividing the difference by k. So I'm dividing the difference by k. Which means I'm saying that, is this guy, can this guy be converted to this current guy? So it is 1. Like the difference is 1, so we can divide it. So maybe this cannot be converted, so that's why we go till here, and now the difference here was 2, which means that this can be converted. Okay, There are some reminders, which means that this part cannot be converted. Now we have 0 to 0, only this element. Okay, whenever we have a single element, we don't need to think, we just have it, as the difference. It is 0, like n minus 1 is 0, and then 1 and 2, 1 and 2. So this minus the difference of this, or the sum which was present here is still the same sum which is present here, which means nothing has changed. Nothing has changed. And this sum can be from here, or maybe it is started from here. Does it even matter? Like, is it from here? Then this is completely equal part. If it is the same guy, like 1, and here it is again 1, which means that here it was 0 difference, again here it is also 0 difference. That's why it is the same. So again this and this is same, which means that again the answer is 1, n minus 1, which is 2 minus 1. Can this create some problem? So we want these values to be in the sorted order. For this to this, I can again calculate using prefix sum, like the difference between this and this, and then maybe deciding the operations based on this. But where will I do this part? Because there will be something in the start, and if I just calculate the prefix, okay, I can remove this, right? Let's just calculate the difference. So thought process is first we'll calculate the difference. Check zero change, we'll just calculate the prefix sum. Then for the first and last part we'll check okay. Then how we'll calculate the answer. For the answer again, what we want is the difference, like the absolute difference between the consecutive elements. Like I'd say for this we want the prefix difference. Like for this consecutive guys we want the difference, and then for this part and this part, if we are calculating, we will just reduce, like this, subtract the answer of this, so that we will just get the difference between these parts, and then we will just get the difference between this part. For every consecutive element, we'll check how many operations are needed for converting this to this. Okay, but this needs to be sorted, right? But this needs to be sorted. This is again a hard part. Like, how do I check? How do I check the answer? For all the elements, I have to convert them to some element some element with the minimum number of operations. With the minimum number of operations. So what I ideally want is I want them in sorted order, and then I can just iterate through them. But iterating is not an option. This part is pretty much sorted. This part is pretty much sorted. But how I'll calculate the answer if I get a subarray? So this subarray can be converted, but what will be the answer for that?